So this is the part where we wait. We wait for us to go live. Are we live? Are we live? I don't know.
Are we streaming?
So at some point this should work.
Oh, it looks like it's live now.
Are we live?
We are
Drew,
live.
are we live?
We are live, Charles.
Excellent. Cool.
All right. So
Drew, go ahead. Go ahead.
I was just going to say, today we have a guest, Anthony Chu, joining us from Microsoft. Thank you for joining us, Anthony.
Yeah, thanks for having me.
Awesome. So I told you a little bit, I guess, about our sort of weekly stream, where we have different people from the industry on the show to talk about different things. So one of the things is, how did you get into tech? How did you get started? Maybe we can start out with that. Tell us a little bit about yourself and how you got into software.
Sure. Yeah. So my name is Anthony Chu. I am currently a program manager at Microsoft, working on Azure Functions, our serverless compute platform. So I don't know, where did I get started? I guess when I was like a little kid, or like an early teenager, I guess, my parents got like a Mac, like some kind of a Macintosh Classic or something.
Oh, nice.
So I actually didn't know that I was programming. There was some stuff on there, and there was like HyperCard or something.
Mm-hmm.
And I was just kind of like building little things with it. And then kind of got into kind of computer science classes in high school. But then I was actually, I don't know, just following my parents' dreams, I guess, and kind of signed up to be like in kind of accounting or pre-commerce or something that would make them happy.
Mm-hmm.
And then, but when it came to actually registering for the courses, one of my friends was like, hey, you're in computer science classes with me. You seem to like it. You should just sign up for computer science courses. And that's sort of what I did. So I just changed my major to computer science and went to UBC. And then after that, just worked at a startup that was around the year 2000. And then kind of bad things happened in the industry and around the world. So the startup kind of went away. And then,
well, around that timeline, that's kind of interesting. So I don't know if that would have been a similar time with when ISO Hunt was around.
That sounds very familiar. Is that like where you download stuff that aren't necessarily legal?
Sort of. You have the trackers for it. It was one of the BitTorrent sites, and it was actually from Vancouver, I think, from somebody who went to UBC.
Oh, really?
Yeah,
I
think he was actually a student when he launched it.
Oh, cool.
Yeah.
Yeah. So, but anyway, like the startup I was at closed down, and then I just went to a kind of like a biggish kind of a forestry company. Just kind of worked in their IT department for a while, and then just kind of bounced around different companies after that.
Focused on programming, or
yeah. So as a software developer, pretty much the whole time. And then slowly became like more of an architect-y kind of a person, but still just more or less a developer. Just kind of did more stuff, I guess.
Yeah, I think around the time that our circles kind of converged, you were with Build Direct, and I think there was something to do with getting on to Azure or using Kubernetes or something cloud related, and Microsoft.
Yeah, so we were actually mostly on AWS there. We had a bit of Azure, but some of the stuff that we were kind of investigating at the time were whether Kubernetes was going to be a thing. So we did a bunch of kind of proof of concepts and stuff like that at that time. So that was a lot of fun. I was able to learn about Kubernetes, something I just didn't know too much about.
Yeah.
And actually that sort of led into me kind of eventually ending up at Microsoft.
That's kind of what I suspected.
There. Yeah. I kind of ended up meeting some folks that just happened to be in the Kubernetes circle that are also in the Microsoft world. And one thing led to another. I joined Microsoft as kind of an interesting role as a developer advocate.
Yeah.
Something that I never thought that I would do. Kind of like an external facing kind of a developer. Kind of just helping people be successful with stuff, whether it's like hopefully stuff that's related to Microsoft, but even if it's just something somebody having a problem with like their React app or whatever, we're happy to help them. And then a few months ago, I joined the Azure Functions team as a program manager, also something that I've never done before.
What's a program manager? Like, I'm kind of curious about that.
Yeah, so at Microsoft, or at least in Azure, a program manager is mostly a product manager.
Yeah.
So you're kind of in charge of kind of the direction of the product, or at least some features in the product. There is sort of like some kind of program management type of things in there as well to make sure that, things are kind of going as planned and kind of just making sure that the right things are being done. But mostly you kind of feel like when you kind of act like a product manager.
Yeah. Okay. Sorry, I interrupt you.
Yeah, no worries. But that's I think that's kind of where we are today.
Yeah, absolutely. So I'd love to talk a little bit about sort of a lot of things, I guess, but Build Direct, right? Like this was a pretty big company, and like I think maybe not everybody like an average end user, not everybody would be necessarily an average end user, but kind of worldwide, this company scaled quite a lot and grew very, very rapidly, I believe, and started and is based still in Vancouver.
I believe so. I haven't really been keeping up with what's been going on there, and a lot of the folks that I kind of used to work with there have kind of just moved on to other things.
Yeah.
So I actually don't know too much about what's going on there. But when I joined, it was definitely at a point where they were kind of around for quite a while, since like the early 2000s. And then they just kind of made a decision to sort of like, let's make technology like a big thing and just focus on, let's build a platform versus just kind of sticking with their, I guess, the previous model, which is just selling kind of building products on a website. So so I was able to join and kind of like be part of actually building some new teams. It was actually one of my the best jobs I've ever had. Some of the best people that I've worked with, I've met there, and we just really gelled. I really enjoyed working there.
Also, some very nice views from that high up. So what were some of the what were some of the challenges and what were some of the things you got to work on there that were exciting?
I
or
thought
interesting or difficult?
Yeah, I thought everything was pretty interesting. So it was fairly old kind of a website. So it was a monolithic kind of an ASP.NET website that we were trying to tease apart. At the time, I guess we didn't even know that we were trying to do this microservices thing. And even now, like kind of just thinking back, I wasn't really sure whether or not that was the right thing to do. But at the same time, I think the whole company had the mindset of we want small teams to own things from end to end and be able to iterate as fast as we can. So so even though I think a lot of us didn't even know that we were kind of moving towards like the small teams, the microservices kind of a pattern, we just ended up sort of doing that. So kind of learned a lot of stuff, probably by doing it wrong. But it was very interesting, being able to be part of that growth and being involved in all those teams, kind of building out new parts of the product that wasn't there before.
That seems to be like I would say a pretty common sort of path to follow is that you organizations find structure somehow, right? They structure themselves somehow, but they're not static. They change over time. Needs change over time. Software changes over time. The teams change over time. All sorts of things are continuously changing. And so when the way that you kind of described that was like, I don't know if it was necessarily the right way to move into microservices or not, but it was the team structuring that was sort of pushing to do that. And I think that's also a pretty common pattern.
Yeah, I felt looking back that I think we sort of did it the right way. I think after the microservices kind of craze kind of came about, a lot of people wanted to do it because they want to do microservices. And they weren't necessarily organized the right way, right? They still had like a giant development team and a giant QA team, and then a really long process for getting stuff out to production. So there were still dependencies everywhere. And don't get me wrong, I think we had a lot of that as well, but at least the mindset was there, and also the team structures were there that I think microservices was actually a really good fit for it. Whereas afterwards, like, especially just talking to various folks, just in the communities when I go out to meetups and things like that. I think a lot of people just, at least at the time, were kind of just wanted to do microservices, but not really knowing what they're getting into or how.
Well, there were,
Like,
I think, I mean, I think it's what you're saying, but I think people wanted to do it because they read articles about it. They saw other people doing it. They just kind of like wanted to go along with it, right? Like kind of conform to what everyone else is doing. The same way, like, a new fashion comes out for clothes, everyone's got to get the new shoes, the new jacket or whatever. But
Well, it's
yeah,
also, I think also there's a lot of talk and a lot of hype and a lot of tools that are coming out that look cool. There's nice stickers and logos. I mean, Docker has an amazing logo, I would say.
Docker's really good at marketing.
Right. And I think there was like a lot of buzz about it. So obviously buzzword, right? But like I remember myself, like I hadn't worked on like microservices from scratch type thing and like kind of built that up. And I think that maybe the way that you described that at Build Direct was like we didn't necessarily know we were going in this direction, but that was the direction we went into. So that's something that sort of naturally came about as a result, maybe, of like organizational change and
Anthony was really getting into, like, I think the thing, like the reason you might do microservices, right, or something like that, right? Like we had this huge code and it's really complex, and maybe like you get a new person in, they change this one thing and it breaks something else. Can you divide the code up into chunks somehow that a single developer can understand it, right? And this is, of course, like that size is going to depend on the developer, how much experience they have and all that stuff, but can you divide it like small enough so a person can understand it? And also it's not, it has like either no coupling or very loose coupling with everything else, so that if I change something here, it doesn't break other stuff, right? But it's something to make your life easier, right? But of course, like if you're just doing it because you see everyone else doing it, you might not know that's the benefit of it, right? And you might also do it in a way that actually doesn't help you. For example, like some people, the jump instantly is to do it over HTTP or HTTPS, right? And create a distributed application. That comes with its own problems. Like having a distributed application over the network comes with its own problems. Like, sometimes it's worth it to incur that cost. Sometimes it's not, right? I mean, you can also do microservices like things, dividing up the software by just, for example, taking your code, putting certain things into folders, right? And they just keep the coupling very loose.
You could maybe call that modular services, and you have or a modular monolith.
Yeah, we should start that movement, the modular monolith.
I think it actually kind of makes sense because you'd be effectively organizing your code base around teams that are responsible for certain things, and they would just be building modules, yet you wouldn't incur the sort of the cost of communicating over a network necessarily.
Yeah, and I think that's what I would tell people to start with. I think a lot of people just jump straight to microservices, but like for all the reasons that Charles kind of brought up, like especially that extra cost and extra kind of complexity that comes with just making it a distributed application.
Yeah.
Like I don't even think we're doing it right. But the thing is, we started teasing stuff apart. And then we're just learning that, like that if we have to update a service over here, but then it requires 3 different things to update at the same time, then we're probably doing it wrong. But I think at the time, we kind of just learned by almost doing it a few times and like, well, that doesn't seem right.
Yeah.
Whereas now I think
error-driven development.
Suffering-driven development.
Yeah.
Exactly. Yeah. Yeah, so I would much prefer to kind of start with something that looks more like a monolith, but have the right seams there, so that if you wanted to tear stuff apart, you can. And like I think you had Adam on last week, right? Like a lot of the thinking that he puts in with like so like a lot of event sourcing in the event driven stuff. Like that's a whole new way of thinking as well. And actually I wouldn't say a new way, but a whole different way that I think a lot of people just haven't thought about yet. And that's another great way to build software. So there's not really one way to do it, but I think a lot of people will see something like microservices a few years ago, and then sort of like the evolution of that is almost like Kubernetes. Like everyone just wants to get that and be using it and be writing microservices, but they don't necessarily know why and kind of like the problems they're getting into.
Kubernetes just got popular. Like you have like people putting it as requirements, getting hired. Everyone's talking about it. It's like, but what does it solve, right? I mean, I haven't actually used Kubernetes, but like, for example, like there's one problem I came up with when I was playing around putting things in containers, right? Let's say, for example, that you have a bunch of, separate servers running, or daemons, or whatever you want to call them. And somehow you have to, like, say it provides an API over HTTP. Okay, like somehow you have to get to that. Like if you're on an IP network, like an internet like network, you're going to have an IP address, maybe, or maybe you have a domain name, and you need somehow you have to expose that with DNS. But like, if I just spin up a container and like it doesn't have an IP address yet, and there's dependencies, it's like, how do you find it? How do you locate this, right? And that kind of coupling, people sometimes talk about microservices, but like you don't end up with a microservice sometimes. Sometimes you have this distributed monolith, right? Like you still have the monolith, you still have these tight couplings, dependencies, but now you have all those problems plus the problems of a distributed, program, right? And I suspect Kubernetes is somewhat attracted to that, but it could be that like maybe the approach to the architecture you're taking maybe has some problems. Maybe this wasn't the right path, for example.
I think for me anyway, I think Kubernetes solves some issues with like once you're in the kind of like the microservices world, like you can spend a lot of time kind of just working with infrastructure to kind of like you said, like, networking and service discovery and stuff like that, that a container orchestrator like Kubernetes does for you.
Yeah.
So you don't necessarily have to worry about how to talk from one service to another, at least how to discover it. They just make it really easy with DNS.
Yeah.
And just making sure that you always have 5 replicas of your application running. They make sure of that too. If you need that to auto scale, that's all built in. So they just happened to be the one that won out. And I could see why, like at the time there was, Docker Swarm and Mesos, I think. But like
there were kind of quite a few, and it kind of seemed like there was about, I don't know, 10 years almost, or 8 years or something of sort of cloud being this nebulous thing, if you will, but like and then people were thinking, oh, it's all about PaaS, right? Platform as a service. And then it was like, well, maybe it's somewhere between the infrastructure as a service and the PaaS, and how we decide what that is. And I think Kubernetes just happened to be a nice sweet spot between the sort of infrastructure and then the platform that gives you the ability to customize and modify things the way you want.
Yeah, I think for a developer, it solved a lot of problems. It also introduced a lot of problems as well. You now have to find people to be able to maintain a cluster, or like, multiple clusters, and be able to operate Kubernetes at scale. So it's just so that you can almost build this platform on top of Kubernetes so that the developers don't have to worry about it.
Yeah. But it also seems, I think, like going back to the idea that, everybody was kind of hyped up about microservices. It seems like there's a lot of problems that some bigger companies that are scaling, that are at very large scale, have, that everybody wants to talk about and everybody finds interesting, but they're not necessarily, they're not necessarily problems that you would need to solve or want to solve, even spend time and resources and effort solving, if you don't have those scaling problems.
Yeah, I would totally agree with that. I think we kind of fell into that trap quite a bit at Build Direct as well. I think we spent quite a bit of time kind of almost following the Netflix model. Like let's kind of build up this platform using virtual machines and auto scaling groups and all this stuff in AWS. When you could just kind of walk over to, even at AWS, you can just spin up Elastic Beanstalk and just deploy your app there. Because at the end of the day, you just want a place to deploy your app that's able to handle things like DNS and domain names and be able to scale in and out. That's platform as a service. And there's no reason to build that until you've hit a certain stage. And to me, like once you get to that certain stage, you should be able to afford to kind of rebuild your architecture at that time, because there's something driving it, and hopefully it's revenue is one of it.
So I think there's like two ends here that you can look at these sorts of things from. One is, why not just use a solution that works, that's implemented, right? Like Elastic Beanstalk, or Heroku even, or whatever PaaS there is out there. And the other is, do you even need anything like that? Can't you just have like something much simpler that you've built from scratch, that you understand every little bit of? So you still have, there's still the cost to sort of learn that. And then as you hit issues, or if you hit issues with what you have, then maybe start to grow with that, or resolve them yourself.
Yeah, I think the value of kind of building it yourself is actually just learning how it works. But I think once you learn how something works, like I think like and it's, I could be biased because I work for a cloud vendor, but even before I joined Microsoft, I thought that you always kind of start with kind of the highest level of abstraction and kind of move down because there is a lot of value in basically building on top of basically solutions that people have figured out.
Like standing on the shoulders of giants, you might say.
Exactly. Yeah. So and
There's
then if you
there's trade-offs to that
yeah.
too, though, right?
Oh yeah. So like the most common one that people talk about is lock in, right? Um, and um, and just not knowing what's going on or just needing that extra control. But I think a lot of those, like you talk to a lot of people, and I think most people you talk to are like, well, how often have you kind of changed your cloud provider? How often have you had to have full control of your DNS or whatever it is, right?
Yeah, yeah.
It's pretty rare. And I think if you architect your application properly, whether you're actually building on like a functions as a service, which is pretty high up the stack, or you're building on top of VMs, your core application should just more or less stay the same. And there might be like a layer that you run on top of that you have to swap out, but your business logic should just be code, whatever it is, Java code, C# code, JavaScript code, that doesn't have any dependencies on the platform itself. So
that's tricky though. Like sometimes like there's a like say for example you have a queue, and maybe users sign up. When the user signs up, you send information about the user to a queue, and then there's some kind of program that's running that gets that and maybe sends them a welcome email or something, or maybe like checks that this isn't like a bot trying to sign up on your system or something like that, right? And that queue is probably going to have a specific real API. Maybe it's over HTTPS, and there's a certain endpoint you have to call, and there's a certain way you have to form a JSON message or an XML message to give it that. Like, I mean, you could abstract that, but like that, you're going to get like often in practice, you often get some kind of dependency.
Yeah, and even like the abstractions on that, you'd probably have to, like you said, how often do you change cloud providers? You'd probably have to have done that a few times to care enough to do so.
Yeah, but I think there are ways to sort of abstract that without adding a lot of complexity. So quite often you just kind of invert that very last bit, invert that dependency on the outer edge, so that you're now depending on some sort of an interface that just says send message to queue. But then you kind of implement that cloud specific or platform specific piece that actually does that work. That is a slightly more work, but then the kind of trade-off or the gain that you get from that is at least a feeling of not getting locked in, and hopefully you can swap stuff out a little bit easier.
So I hear a lot like the idea of vendor lock-in, right? Oh, I don't want vendor lock-in. You don't want vendor lock-in. Comes up quite a lot, but like, why do people care so much about that? Any ideas?
I don't know. I don't want you to tell me what to do. So I always want to have kind of like that control, right? So
it could be also maybe there's like a terms of service change or a price change, and they, for whatever reason, they don't like it and they want to go somewhere else. But like if your code is highly dependent on that system, you can't switch. Well, it's really hard to switch.
Yeah, even in a pretty good case scenario, it would still be a lot of work, I would think.
Yeah.
But yeah, I mean, I guess price, right? Cost, for example, could be a thing, but then the effort to sort of develop your systems in a way that you could switch relatively easily based on cost would be, it seems like quite a lot of overhead. I guess there would be some cases for doing that, and I've heard of some companies having their systems replicated across different clouds, and I think even with Kubernetes, there's like cloud federation, right?
So I think you can always do that, but I wouldn't start off doing that. I think especially like usually you're talking about building a new product, and especially in the last 10 years, I think the approach to building new products have really changed. You really kind of just want to get something out there just as soon as possible to get that customer feedback so that you can iterate and hopefully out iterate the competition, right? That's the goal. Like quite often you don't necessarily need to move that fast. But just being able to do that, just having that nimbleness of building on top of someone else's platform usually gets you there a lot quicker when you're at that stage. When you get to a point where like you usually look for like signals or kind of pressures that will kind of push you towards changing your architecture, but usually you I don't know, like from my experience from just people that I've seen, you're just able to get to be like you can get to the point of getting your code out, getting your application out there or your product out there a lot quicker by building on top of something else, and then almost just deferring that decision to move to something else far down the road.
There's some things like I mean, like I think like 20 years ago, like there wasn't really a separation between back ends and front ends. Like you had a software developer, a software engineer, programmer, whatever the new hotness for the name is now. That person did what we now call back end. They did what we now call front ends. They were the DBA. They managed the database. They structured it. They were the operations or sysadmin or DevOps or SRE, whatever we're calling it these days. They did it all. And I think like fast forward, like when these kind of like cloud providers started coming up and providing the infrastructure, it was like, like I can do all that, but it's a lot of work to do like this sysadmin, operations, DevOps, SRE stuff. Cause I've got to like monitor these computers. I've got to, check if they're going up or down. I've got to update the software all the time. That's a lot of effort. What if someone else could do it? And what if it's like, it costs a lot less than like hiring someone, right? And I think that's what like, a lot of these cloud providers, like the one that you've been on, Microsoft Azure, I think that's part of what they provide. It's like, I don't have to do this now. And, it might make sense like after your company's grown quite a bit. I mean, like I know, I'm not gonna say which company, but one company I helped build, I remember at one point our monthly bill was $300,000 a month for, servers and all this stuff, right? So not a year, a month, $300,000. So at that point, it's like, well, maybe it might make sense to like get your own hardware. But in the beginning, like for a long time, like it's just a lot easier. Like salary costs money too.
But it also might not even at that stage. It kind of depends, I guess, on where your customer base is, what sort of things you're serving them, how much, how much value are you getting for that $300,000 a month? Because I was actually just thinking about that. Like, I guess you could obviously do the math, and it depends on the company and whatever, but even like games companies, I've noticed that the cloud providers have services for launch your game on our platform.
I think games in particular, I think they can take advantage of the cloud a lot because of just the way that the workload, like basically like when you first release a game, that's when you get that big, hopefully a big kind of rush of people playing your game. But then like I've seen some of these curves, it kind of just dips pretty quickly. And if you're kind of using your own hardware for it, like, you only really you have to pay for basically that peak. And then you don't know what to do with it after, right? So I've seen game companies in particular, like and startups as well, getting
conferences too are a big one. I'm not gonna say which one, but I did work for a very large game company a couple times. But I know, like, you'd have the servers, and they'd have a certain level of traffic, and then they'd get on stage at the conference, bam, like it just spiked, right? And like their level of traffic is huge. And then there's even other things where like game downloads, that's a big deal for them too, right? Like you have the binaries that people are downloading. And I know at that company I was working, doing work for a couple of times, they had a whole department. So they were like half a floor who their job was to negotiate with a content distribution network just to get that deal right, because their traffic was so heavy, right? Like the deal mattered. Like it could like really affect their bottom line, which is kind of interesting. And like there was something like I wanted at the time. I was trying to build this distributed reinforcement learning system to kind of like make decisions, like let's say AI for the people who are like, although software developers would probably call it machine learning, but I needed the programming aspects. So like some people are used to like edge size includes, where you can kind of like, it's not just you cache stuff using the CDN, you have some kind of logic that happens. You can maybe import something that's kind of dynamic. But then there's stuff where you can do like if statements, you can do cases, you can do loops. You can also do random numbers. So I mean, like you get that, you start able to do some machine learning, right? And I needed that. And I had to go through this department, and like it was challenging, right? Because the price really mattered for the company. And I was like, I just want them to turn this on. It's like, okay, this is going to be delayed for like a year, which is kind of interesting.
Yeah. Okay. So let's talk a little bit, I guess, about about serverless compute, about functions, serverless functions as a service. What is it? How does it work? When would you get started with it? Is this something that's like a step toward microservices or away from? Is it a different way to architect your system?
Okay, well, that's a lot of questions. So I guess let's start with what it is. I guess there's, yeah, like I'll go with kind of my definition. I think there's, like, I think most of the definitions are kind of the same, although like lately, especially when folks from marketing get involved, I think a lot of things are called serverless now. It just becomes a buzzword. But like my definition of it is, obviously the first one is you're kind of abstracted away from the notion of servers. You don't even know the servers are there. Um, Obviously there's a server somewhere that someone's running for you, but you don't know that it's there. And quite often, at least with the functions as a service, you're not even deploying, like if it's a Python app, you're not even deploying like a Flask app or a Flask server. You're just literally deploying the piece of code that runs, for instance, when like your Flask app would have gotten an HTTP request, or you're just writing that piece of code that runs when a queue message appears on a queue. So you're kind of, at least a couple notches up the stack from if you were just deploying to a platform as a service, where you're actually having to kind of
and so is that piece of code like some sort of like a handler?
Yep, exactly. It's just a handler. Quite often it's literally just it's just your business logic and nothing else. So quite often, like if you're creating like a web app, you would create, you have some kind of like scaffolding and like middleware and stuff like that you kind of have to build, and then deploy this whole thing to a cloud and maybe figure out how to scale it. But with functions as a service, you're just writing that piece of code that only you know how to write, because it's your business logic, but you kind of try to abstract away or kind of ignore most of the things, like what triggers it, or how to scale it. And that kind of leads me to like the second point, which is usually serverless compute is event driven, because that's where it kind of shines, right? So you want your code to be able to be deployed somewhere without you worrying about it too much. And then if you just get a shock of traffic, you just know that the code is going to be, just more instances of your code will be spun up and it'll just do the work.
Yeah.
So it's able to do that. But conversely, if you're not getting any traffic at all, so say you write an app that's just for, maybe like holiday shopping or something like that. So you only have, maybe 1 or 2 days where you're actually getting that spike in traffic. The rest of the year, the code still sits there and it's still listening for events, but you're not paying for any events. And that also leads me to probably like the last part of serverless. And that's the part that I think it's a little bit more controversial, because a lot of people tend to kind of bucket platforms as service into serverless as well. But I think true serverless should be pay per transaction or pay per request. So if your code is just sitting there doing nothing, you shouldn't be paying anything. But when you need it, and we actually scale up for you to many, many instances, that you just pay for the requests. So you almost kind of like offload the like almost like the harder parts of how to kind of build out the infrastructure for like a highly scalable system to somebody else. Sometimes, like for platform as a service, a lot of people run that in-house on a Kubernetes cluster themselves. But even then, right, as a developer, you don't think about it at all. You're just deploying this function. Yeah. You do have an ops team that's actually managing the cluster, making sure that you have enough capacity, all that stuff. But that's somebody else's problem. So that's how you kind of get, I guess, like good velocity as a developer, because typically you just think about the code that you have to write.
So that actually seems really interesting. I have a couple of questions, I guess, which are, is that then sort of platform dependent? Are there things that come with that, like that maybe you get for free? For example, like if you're on Azure, then with an Outlook address or whatever authentication that you use through Microsoft, then now you can just manage your maybe your developer permissions, but also even user permissions, things like that.
Yeah. So I guess I'll answer the first one first, which is like whether it's kind of platform dependent. I think once you get into like the functions as a service world, at the end of the day, you're just writing a function. And how much of the platform you decide to bring into the function is really up to you. So like obviously you need to write to a database somewhere, right? But do you like, well, you might have to write to a database somewhere, or you have to write to a queue somewhere. But again, it kind of goes back to, do you have a hard dependency on this thing that's on my cloud that I'm actually like writing out to, or do I have a layer of abstraction that you write to so that your main code, that main function, like 90% of it, maybe even offload that to like, if it's Node, just a Node module that only knows about your business logic, but doesn't really know how to talk to the infrastructure, and you kind of plug in other things actually talks to the infrastructure. So you have this piece that is yours, and you kind of have just like a small adapter layer that that allows you to kind of work with the platform. So I think that's kind of up to you. I think, and also for Azure Functions in particular, we kind of provide you some ways so that we actually do that abstraction for you. So, so for instance, you can have a function that's triggered by an HTTP request, but then we also have these things called input and output bindings. So what they are is that instead of pulling in an SDK, maybe pulling in SDK for our Cosmos DB database, which is our kind of NoSQL database. So if you pull in that particular library, then you kind of, you kind of, I wouldn't say locked in, but you have a dependency on that library now. Right. To kind of read data and to write data. What you can do in an Azure function is that you can just define an input binding and an output binding. So they can say, hey, when my function triggers, in this case, maybe an HTTP trigger, go take the ID that I'm passing in as part of the URL or whatever, and go over there to, in this case, maybe Cosmos DB or some other database, and actually pluck out that record for me. So the very first line of code that you write in your function, you're just working with, if it's JavaScript, just a couple of JavaScript objects. One that represents the request, and then another that represents the record of the records told it to pull in. And you can have multiple of these input bindings. You can also have output bindings. So same thing, instead of pulling in an SDK that writes to, your object storage or queue to send out other queue messages, or even like do things like, sending messages over WebSockets. You can instead create a binding. So what you do is you just return one of our objects, and then just leave it up to us to basically convert that to the thing that you told us to do. So whether it's saving a file out to object storage, or turning that object into a database, or like a database record, or a queue message, or WebSocket message. So your code is just basically taking in a bunch of objects, working with it, and then just returning objects. But even without that infrastructure in place, like without that capability, I think you can still write your code in a way that you try to abstract away some of that stuff if you care about being abstracted away from it.
Mm-hmm. Yeah, that totally makes sense. So it sounds like you gave us a couple of pretty good examples there. So on the one hand, it's up to you really as the developer how much you want to depend on vendor-specific dependencies. For one, with just the way that you write your code, but then on top of that, the Azure is able to sort of infer some things based on what you say. So if I say, oh, here's my my binding, I want you to store this object in whatever I'm using as storage, and that happens to be Cosmo DB or whatever it happens to be, then it will be able to know how to handle that. And so that in that way, it's kind of encouraging you to write your code in a way where that's abstracted.
Yeah, and then if you were to take this code and run it in some other platform, you would just have to basically write an adapter around this thing so that you still pass in the right objects and take in take the right objects that are outputted and just do the right things with it.
Oh, interesting. So yeah, that actually sounded, I was going to ask like what would be a good use case to get started with something, but I think you've almost walked us through some already, like, holiday, if I have like a holiday shopping list, for example, or maybe a site where you can create your own holiday shopping lists. with reminders, and maybe maybe you could have something be a little bit fancy so that you get you can choose what you'd like, and then um, there'll be some, you know, geolocation based prices that you can go and check them out. And so when you come somewhat near a location, then you'll get sent a message or something. Although I guess it would probably be just easier to have that give you recommendations for where to buy it online.
Yeah, I think all of those are pretty good scenarios. I think usually where I see people get started with serverless is it's like almost like adding a piece of functionality to their main system.
Mhm.
But then they're like, well, instead of actually just ripping apart my current system and try to, you know, basically add that feature to it, let's try using serverless for it. So some cases that I've seen are, so for instance, if you want, you know, an email to be sent out whenever like an order gets created, for example, like you could kind of change change application and put that in there, or you can just listen to an event. So if your main application happens to send out events on a queue, then maybe it makes more sense to create this function that listens for queue messages and then does what it needs to when you see an order created message.
Yeah.
Right. So we see people like starting off just adding like, you know, just little functionalities here and there. Sometimes it's things that they would have stood up a server for, but they no longer need to do that because they're just kind of leveraging, you know, like a serverless platform. So and then most of the platforms like ours or AWS's, we give you like 1 million executions for free per month. So a lot of people can get away with not even paying anything for creating this new piece of functionality. So we see a lot of people doing like basically building like glue type stuff with it as well. So gluing various kind of systems together using serverless. And then some of them eventually get to the point where it's like, well, I'm comfortable building stuff this way, that maybe I can build a full serverless API with it, or maybe an API plus a bunch of backend queues, and actually like, you know, build up a pretty elaborate system using like basically serverless functions. And then you asked about, you know, how that relates to microservices. I think like any other technology, you can you can use it in the way that works well for you. So if you do want to, for example, put together a few different functions together into like a serverless API, maybe you can call that a microservice, right? So you could kind of build microservice type things with it. A lot of microservices these days are event driven. So they're kind of, instead of working over HTTP, they're actually asynchronous over queues and stuff like that. So queues are pretty natural for serverless functions because you have a platform that takes care of listening for messages and spinning up functions for you. So you just write the functions that have to execute whenever you get these messages.
I guess one thing that I don't know if it comes up a lot. I'm actually quite curious. Is are people worried that it's now sort of scattering the complexity all over the place, and then how do you manage it? It might seem like one serverless serverless function, whatever. It might just be very easy to understand and comprehend, but when you have, say, 50,000,
Yep. Yeah, we like I lived through that. At Build Direct, we did start that way. We're like, oh yeah, like there's Lambda, we can use it.
Yeah.
And then we're like, well, this is great. Let's use it everywhere. And it's usually, you know, something that's driven by developers, even though, you know, like our team is kind of, you know, we're in charge of kind of deploying stuff as well. But usually, like you kind of take that developer mindset. Let's build some stuff. Let's check it out there. Next thing you know, you have like 30 different functions out there with weird names, and you don't know what they do or who owns them, right? So, so I think
or what depends on them, maybe, right?
Yeah, and then you definitely have the potential to kind of end up at a place where you're actually worse off than you would have been if, like, it's like, you know, the other kind of way that you could have had this mess in the past was if you let people just deploy random, you know, node apps or, you know, Flask apps or whatever everywhere. But at least those things are kind of bigger, chunkier. Whereas now you have these really granular things that people are deploying everywhere.
Mm-hmm.
So if you don't apply the same kind of, like the DevOps or whatever best practices to it, you could end up getting in trouble, and you get in trouble pretty fast from what I've seen.
I got a question. Just kind of get into this stuff. How do you go about testing stuff? Like, let's say you're writing all these functions, and it's in the cloud essentially. It's not really on your computer. Like, I mean, there's some challenges of that, right? Like, one, how to create a development environment. Is my development environment on my laptop, or do I always have to push stuff to the cloud? And then, okay, if that's my development environment, how do I test stuff? Like, can I write a unit test? Can I write a functional test? Can I write an integration test? Like how does that all happen?
Version control as well.
Yeah, like how do I put this in Gits? Like, is there an easy way from going from development to maybe a QA server to a staging server to a production server? Like how does that all like play out?
Yeah, so I think for something like what was your first question?
So let's three questions there. The first one let's tackle is like development environment. What is it?
Development environment. Yeah, whether it depends on the cloud. Yeah. So I think a lot of what you do with a traditional web app, for instance, can apply to functions, just at a slightly different level. Like again, goes back to what I was saying before. If you can sort of separate out your business logic so that you can drive a lot of it with unit tests, that's great. But you do tend to have like a lot more of these boundaries now between your app and some other thing. That requires some sort of integration test. Whereas before you kind of have like basically a process is running that's got multiple things running in it. Some of them still might interact with the outer world, but it's kind of like a more, like a more defined boundary. But now you have a bunch of little things, and then they all talk through a different system. So there are those challenges. And there isn't a super easy way to do it. Usually you do need to either set up some infrastructure yourself in your kind of like your CI/CD pipeline, and spin up all these functions and have them kind of talk to each other. You usually end up kind of pushing some of that to your pipeline, because you typically would want some of these functions to be deployed to some kind of environment where these things can be kind of almost end to end, or at least tested using integration testing. So you do lose some of that, but at the same time, because a lot of these are functions now, so you can drive a lot of these because they just take in objects and they return objects. That you can sort of test a lot of these without any kind of framework, but to see them all work together, it is a lot harder and the other thing is you do tend to see people use things like queues a lot more. So whether you're building a traditional application or using like a functions as a service, queues are hard to test. And the fact that you're now saying that it's really easy to spin up things that talk to queues, and queues tend to be the glue between everything. And there, like, to be honest, there isn't a super easy way to test it without spinning up all of it or a portion of it that all work together to test it out.
There's like, I remember like with one of the companies I built recently, there was a file we had to download. It had a whole bunch of records in it, right? And like you think, okay, well, one approach, I'm not saying it's the approach we took, but one approach is like you take that file and then you parse it and split those records and just toss that on a queue, right? Like each of those separate records. And then something else reads that in and processes each of those records. And maybe it passes that into a queue and something else processes it, right? Like it's kind of like the pipeline you have on the command line, just like more complex, like in a sense, and kind of like, hiding the nice syntactic sugar you get on the command line. But like, I remember like, okay, if we wanted to develop, and I didn't think this was ideal, but like, I didn't do it myself personally, but like we spin up a RabbitMQ server, on the cloud, right? And like each developer had their own RabbitMQ server, because you don't want to step on other people's toe. What if they change the format and you throw something in there and all of a sudden it breaks their code, right? And there was, I mean, it's a trade-off, right? Like you end up getting this new complexity into it.
I do see that you can get around a lot of these by spinning up an environment, and also containers comes into play as well. So if you're using things like Kafka and RabbitMQ and like Postgres and Mongo and things like that, like all of those can be spun up in a container. Like even for us, like we have like this SQL Server massive thing that people usually think about. Like you can now spin that up as a Linux container, right? So pretty much everything can spin up as a container. So it really helps. You can just have a Docker Compose file that more or less spun up everything for you.
Yeah.
And you can kind of test that way.
Yeah.
But one thing that I wouldn't say you cannot test, but a lot harder to test, because you now have a more distributed architecture, is being able to test when things go down, whether it's the other service. It might not be a big deal if you're going through queues, or it could be a queue itself going down. Whether either when you're sending in a message and it's not there, what do? Or it receives a message, but for some reason something downstream doesn't get triggered for a while. There's a lot of these things too that now you have to test for. That are really hard to do.
Yeah, there's also some other complexities. Like sometimes when you're developing the software, you have one instance of that function or whatever that's running, and it's fine. And then you add 2 or more, right? And all of a sudden, like everything's falling apart, everything's blowing up because like, oh, you didn't expect 2 things to run at the same time. You've got some kind of race condition or whatever that's screwing it up.
Yeah, and with serverless, the other thing that we see quite a bit is because there is almost infinite scale. Sure, your code can run really fast, but like, are they all hitting the same database?
Yeah.
So yeah, we see that quite a bit, and like a lot of the cloud databases
denial of service as a service.
Yes, exactly. Except you're doing it to yourself, right?
Yeah.
So that is a problem, and we're like, funny enough, we're actually like introducing some more kind of concurrency controls because some people are interacting with, for instance, like on-premises systems with serverless. So, it can have unbounded scale in the way that the functions run, but then they're literally hitting somebody's servers that's living under the desk in the office.
Yeah.
Right. So, so you got to be careful about that. So we're starting to introduce some more of these concurrency controls because we are seeing people interacting with things that are not necessarily cloud native or auto scaling or serverless. So, so a lot of interesting things to kind of take into account.
Okay, so the second of 3 things, the first one was development environment. We talked about that. The second one was how do you go about testing? I think you touched on it a bit, but like what does testing look like? Like, if I'm writing stuff on my, just my laptop, I like, depending what language I use, I tend to use Go when I program, but I know how to write a unit test, right?
Yeah.
And I also know how to write like integration tests and functional tests and all that other stuff. Like, how do you do that when it's on the cloud? Like, what do you do?
You make sure you get a really big internet pipe connection. I think most of that you can still drive with unit tests and integration tests, right? And like I said, locally, if the service that you're kind of talking to has an equivalent that you can spin up on like you say, basically in a container locally, or has an emulator of some sort, you can get by quite often with that.
Especially if you're just looking at the function basically on the bindings, right? What's going in, what's coming out. You could probably simulate that locally and then kind of get your unit testing, get the logic down. And I suppose you'd also, like you said, you're only really paying for when you're using it, not for having it there. So having a sort of integration testing environment, maybe with different endpoints for testing, obviously, seems like a no-brainer.
Well,
that works for a lot of people, but then like a lot of people do want to do things disconnected as well. I think that's where it gets a little tricky. Like it's I don't have a good answer.
Do you remember like there were times when, for example, GitHub went down, and like your company may or may not use GitHub, but you might use a lot of libraries on there. And if you don't store the repositories local, like in your repository, and you depend on them like as part of the build to get pulled down, all of a sudden you can't deploy, right? And like
well, especially for Go, like
I mean, I tend to like check in local copies of the repositories. So I mean, like I learned that the hard way. Like I remember GitHub going down. I remember at a very big video game company, nobody could deploy. A lot of people couldn't do anything because like GitHub's down, right? Or for example, the internet goes down.
Yeah, right? Somebody deletes a branch.
I have stories about that. I'm not going to talk about that. So here's a question. You talk about Cosmo DB and you talk about an emulator. Is there an emulator for Cosmo DB that people could use? Like, let's say they want to write like unit tests and they want to like do the full integration test. Like I want to do some stuff and I want to go look at the database and see if I got the data in there, right? Like, is anything like that available where they need to spin it up in the cloud?
So Cosmos DB currently has an emulator that only works on Windows. It
Okay.
ships as a Windows container.
Okay.
So there, and I would hope that the Linux version should be coming hopefully soon. So there are ways to spin that up. And Cosmos DB, how it works is that it has its own kind of native API, but then you can also say, hey, I want to talk to you as if you're Mongo.
Okay, that's useful. That's useful.
Yeah. So you can still use the same Mongo drivers that you use in your Node app or whatever app to talk to it. And then in that case, you can actually, for a lot of tests, you can just spin up Mongo in a container as well.
I mean,
or if you want to use it as a graph database, you can just basically spin up, like a Gremlin server locally or in a container and talk to that.
Yeah, using Mongo isn't perfect because there could be like slight differences, but it's pretty good.
Yeah. Oh yeah, of course.
Yeah. Okay. So the third question of those things was deployment, right? Like, okay, I have my development environment, whether it's local or it's on the cloud, and then all of a sudden, okay, I need to like somehow like get this to QA. QA is going to look at it, and like, so that's an environment I deploy to, and then maybe QA says, okay, it's ready. Let's have people, maybe the customers, maybe a beta group, maybe whoever look at it. So let's push it to a staging server. People get to look at it there. If all looks good, we then push production. Like what does that look like on Azure?
So we have a kind of like a CI/CD platform called Azure DevOps, because we just decided to name it DevOps. So within it, there's different kind of sub-products or products. So one of them is Azure Pipelines. So you can sort of think of that as like a managed Jenkins, for example. I happen to think it works a lot better than Jenkins, but that's where you would typically put your CI/CD workflows in there. So it can trigger off of, like its internal Git repository or something like GitHub. And then, so basically you can just have it do a build. It basically just come up with some artifacts and then take those artifacts in a release pipeline. Okay. And then you can orchestrate how you deploy it. So in a more traditional way, you might deploy to like a CI environment, a QA environment. You could have like, manual approvals and stuff like that in between. Or you can actually have like automatic gates in between that actually, like, those gates actually call a function that does a check to see to make sure that your app is okay or whatever condition that you're waiting for. Yeah. So you can actually deploy stuff in rings, for example. So you actually deploy directly to production, but you do it in a kind of a controlled way so that you can catch errors or problems early.
Okay. Interesting. Okay, so you have the control you necessarily, can you do rollbacks? Like if that was, because you have the artifacts, it sounds like. So the artifacts would be like, you take your code, you can maybe compile it. There's a binary, maybe there's some config files, maybe you package this in a container or not. So that's an artifact. So I'd assume you store a history of these. So you have a bunch of them. Maybe the one from today we just put out, the last release, the release after that, maybe so far back. And then we push this production, even though it passed everything, crap, like something really bad's happening. Let's go back if we can.
Yeah, so there's a couple ways to do it. One is definitely you can just choose an older artifact and just be like, oh crap, shoot, that's out there. We also have this thing called deployment slots. So so in a function app, you can actually have different slots in there. So you can actually deploy to like a deployment or like a staging slot first. That thing has its own endpoint. So if it happens to be an HTTP trigger, you can actually go and call it to make sure that it works. And then it's a really simple kind of literally like a REST call or a button in the portal that does a swap. So you and then in this case, your oh crap is literally just clicking that button again and it swaps it back. So that's a couple ways to do it. Although I would say for the most, I think a lot of people have kind of moved on to, I wouldn't say moved on, but started adopting the idea of like, let's try to roll forward whenever we can. So you do end up reverting something or making a quick change and then making sure that goes through your entire pipeline before it hits production again. Because there's usually, like when something is going wrong, it's probably the worst time to sort of almost breaking out of your standards of like using a pipeline and just almost like logging. Well, you're not logging on the machine and changing code, right? But in a sense,
roll forward. So you did also mention continuous integration. So does that mean we can also like have a test suite that runs, right? Like maybe code gets committed, and if maybe just automatically when it gets committed, or maybe based on something else, we have a whole bunch of tests and they just automatically run. Like, think our smoke tests. Like, this doesn't cover everything, but like if these don't work, like something's seriously broken and this should not progress any further. Like that can happen all automatically with with this stuff?
Yep, absolutely. So in the build phase of the pipeline, you can just run your normal unit tests, your maybe even some integration tests. If you can kind of spin up stuff in the pipeline in the infrastructure. And then when you deploy it, you can also have different parts of the tests run. So you might mark some tests as smoke tests, for example, that will take an endpoint or whatever it is. So in between or right after you roll out to a certain environment, you can tell one of these, like a subset of these tests to run. And you can also actually that success of those tests can actually trigger like a further rollout if you wanted it to.
Yeah, and because you have gates, like you can say, okay, this progressed to QA, it passed all the automatic tests, but now QA has to decide whether it goes forward. That allows you to bring in any kind of manual testing you might have. So for example, maybe part of your regression test or whatever, like we for whatever reason, we can't write an automated test for this, or maybe it's a new feature, like we don't have automated tests yet. We have people who have to step in there, and then they can just decide for themselves, does it go progress or does it it failed, and we have to change something or whatever.
Yeah.
Okay, cool. So it seems to cover the things that most people want, which is great.
Yeah. I think we try to give as much control over that experience as possible. But like we talked about earlier, no matter how much we give you, a lot of this testing is harder just because of the inherent way that is using queues and things like that you typically don't run into in a more kind of larger, kind of a more kind of monolithic, if you want to call it, architecture.
Or more centralized, at least.
Yeah.
What about are there any sort of out of the box, I guess, because you're on Azure and on that platform, are there any tools to help sort of conceptualize or visualize the overall architecture of your apps that are maybe built solely or partially using functions?
I've seen a couple. I'm not sure if there's any official ones that are going to be hey, just point it to these resources and just show me what it looks like.
Yeah.
Because quite often a lot of these things are configuration settings that actually tells you what talks to what. You can definitely see some of this in a running application. We our telemetry and kind of what do we call those things? Our telemetry platform, I guess, until I come up with a better word. I think
analytics as well, maybe.
It's called application insights, and if you kind of instrument different parts of your app with it, you can actually do distributed tracing with it. So it'll figure out after it kind of observes how your app's working together. You can actually see a view of all the different parts of the app calling each other. And then it'll even tell you basically the lines will have the latency, as well as what percentage of the calls actually worked. And you can also either click on the nodes or the lines to actually dig into more things about either the application itself or the communication between the two applications to kind of drill into errors and all the way down to a stack trace.
Very cool. Yeah, I suppose one way that you could do it too would be to sort of work backwards from the database layer and sort of say where if my application distributed across data that accesses these databases, which what's hitting them.
But there are a lot of these are built into tools now, and there are even standards in how we do tracing, HTTP headers and things like that. So it's a lot easier to do than 5-10 years ago when you're essentially not really knowing what's going on in your system.
Yeah, very cool. So now you've got me excited about this stuff. So if somebody wanted to get started, is there what sort of resources are there? If I wanted to just poke around with it, is it expensive to get started? Are there sort of tutorials? What sort of documentation might you recommend? Is there a sort of project a typical Hello World type one that you might point us toward?
Yeah, all of our docs are at docs.microsoft.com. So you can go there.
A lot of docs there.
Yeah, but you should be able to find Azure Functions pretty easily. And we also have a Learn platform. And what that platform gives you is not only instructions and things like that, but it actually spins up a sandbox. And I think you just need a GitHub login in order to use it. So it should be completely free. And so some of the stuff you can you can learn about, obviously, Azure Functions and things like that. But I think we're also starting to put out just general kind of programming type of courses on there. They usually take about half hour to an hour to complete, and and it spins up a little sandbox, so you don't have to worry about even getting an Azure subscription or anything like that. It kind of gives you all these resources that you can spin up in there. And
is that docs.microsoft.com/learn/Azure?
Yeah.
Yeah. Okay.
Oh, interesting. I went to a different place, but it also looks like there's just a ton of information. So I went to docs.microsoft.com/ENUS Azure Functions, and there's all sorts of, there's like quick start, learn, video, and it's actually organized in quite an interesting way, I think, where so it's got like an overview, concept, learn, and a video, and yeah, I like that actually. So I think maybe we can dive into that at some point, Charles, on our stream, and kind of go over that. And maybe you could join us at some point if you have time in the future, Anthony, to walk through some of these with us, maybe.
Yeah, you bet. Happy to do that.
Yeah, that's really cool. So what sorts of what I guess maybe that would be one question. What sort of situation have you seen that using Azure Functions was like a really good win for people?
Yeah, I think we already talked about quite a few of them. We're starting to see people using it for like automation type work as well, because like you can just trigger a function that runs on a schedule, or you can listen for things that happen in Azure, like like a VM got created or something like that, and you want to make sure that you provision it with maybe just just tag it with the right stuff, so that when you're looking at it like a month later, that it has the right tags, for example. Functions can do all that. Functions, they all have their own identity, so you can actually say this function is allowed to do this on these types of resources, so that they're there's really scoped, and just really writing a couple lines of code to make that work. So we're seeing a lot of people do that as well. Yeah, like I said, like a lot of kind of processing of really like queue messages and anything. Like we're seeing a lot of Python customers coming on board, and Python, like a lot of kind of data science type workloads, being able to do machine learning inference at scale. So I see a lot of people like they just have like a big data set that they want to just go and classify or whatever. You can actually do a fan out, fan in. So you can fan out to many different pieces, like like behind the scenes, many VMs behind the scenes, many instances of your function to actually do this work. And then we can fan back in to a function that can aggregate all the results together, for example.
Would this be for the data science stuff? I mean, there's a couple of things I imagine, and you can tell me if that's correct or not, that they might be interested, right? One might be like, the format that you get your data in is not ideal for your machine learning stuff. So you need to process it somehow, right?
Yeah.
So I can imagine there's that, but they're like, most of the time when people do machine learning, AI, data science, whatever you want to call it these days, they often do what's called supervised learning, right? So you basically like you kind of program things by example. I have a function or a method. I'm not going to program the insides, but I'm going to like get a bunch of examples. For this input, I want this output. For this input, I want this. It's almost like writing a unit test. And magic machine learning, go program this function for me, right? So there's also that what we call training. That activity is called training. Or parameter estimation if you're from another background, but like that process, like is it the kind of cleaning work, the data munging type stuff, or is it like the kind of training part that they're using it for?
So we're seeing a lot of people using it for inference. So once you have that model, being able to
so they're actually executing the model.
Yeah, so you can execute the model. We're seeing most people doing that. A lot of data cleansing as well. The training part, we do have specialized services to do that. So we see fewer people doing that because a lot of people do end up using, at least when they're starting out, they would start using basically some very kind of managed services to do that. For instance, like instead of like writing your own, TensorFlow code or whatever to actually like recognize something, you just go to like a custom vision service, give it like 1,000 pictures and you tag them all. And then out comes a TensorFlow model. So you can do that all in Azure, and then you can just like almost like if you wanted to just click around, if you don't even want to write any code at all, you end up with the TensorFlow model, and you can take that and plug that into a function, and then sort of use that to kind of do your inference.
Yeah, I mean, some of these models, like once you get them, they're pretty simple. I mean, they're a bunch of like multiplications and adds, and maybe some non-linear things. And like the training is like usually the hard part, and the cleanup is the hard part.
Yeah.
But although you do get some models that are like pretty nasty to work with and gnarly, but separate issue.
Yeah, it's usually getting the data into the right shape to pass to the model. Like usually running the model is actually not that not even that intensive or that difficult.
If people are cleansing, like some of these data sets are huge. Like imagine you have like video data or image data, right? Like getting that over the internet, like not only is it going to probably take a while, it's going to be insanely expensive. It might be cheaper to like put it in a card and drive it to your office, like drive it to Microsoft, right? Like
yeah.
What's your experience with that?
Yeah, so there's a couple ways to fix that. One is if you can manage to have your data like where it's generated, kind of keeping everything in the same region.
Yeah.
Then you don't have to pay the egress costs and stuff like that. So you don't have to worry too much about it. Another thing that we haven't talked about yet is at least for Azure Functions, we are pretty much 100% open source.
Yeah.
So what that means is that you can actually run functions, Azure Functions, in a Kubernetes cluster, or even just locally, just somewhere as a process. So if you wanted to, you can actually have that running close to where your data is. If that is your main concern.
That's like it being open source to me would seem like a big attraction, right? Like I mean, like if you complain about the lock-in, it's like, well, you know what, you can take this with you, right? Like you're not really locked in. You can use it like, on Microsoft Azure, but if you ever felt like for whatever reason you want to leave, take the code with you. Right?
Yeah, so I think we haven't seen a ton of people do that yet. A lot of people are attracted to it because their organization just standardized around Kubernetes.
Yeah.
And some of them just want to have access to the programming model of being able to just write functions, but just have it running on like whatever the IT department told them to run it on.
Yeah.
But the lock-in part is definitely part of it. A lot of the bindings do work with Azure services. So if you want the best experience, like basically if you want kind of like the breadth of all the different services that you want to work with, without limitation, you do end up, basically having those as triggers or bindings, right? So teasing those apart and kind of bringing it somewhere else might be slightly harder. But we do have bindings and triggers for things like RabbitMQ and Kafka. And when you run it, we actually provide you, I think some people have even created triggers for like AWS type things. So another thing that we have in the cloud that we don't usually talk about is like, it's a thing that actually, it's a service, it's a multi-tenant service that we run called a scale controller. And that's the thing that actually controls how things scale in and out. Obviously you don't see that. We give you an open source version of that to run on Kubernetes as well. And that thing is called Kata, Kubernetes Event Driven Autoscaler.
Yeah.
And that thing actually has providers for AWS SQS or even like GCP PubSub and things like that. So if you want to be able to scale things regardless of where you are, you can use that scaler along with functions to try to get some sort of vendor independence, I guess.
Yeah.
Is there
go ahead, Drew.
Oh yeah, is there any sort of language dependency for Azure Functions?
So we have I think 5 or 6 like fully supported languages. So C# obviously because it's Microsoft, C#, F#, JavaScript, TypeScript, Python, PowerShell, Java, probably missed a couple. And then we also have another feature called a custom handler. So if you want to write a function in something that is not one of the ones I listed, a custom handler is just basically an HTTP server that you can write. So anything that can listen for HTTP requests can be a custom handler. So if you wanted to write a Go function, you just basically wrap it in a little HTTP server. And so whenever either an HTTP request comes in, we just forward it to you, or if a queue message appears, or whatever you decide to say, to get functions to be triggered on, whenever some of these things happen, and even if you have input and output binding set up, we'll basically the runtime will do all that work for you, collect all this data, and then invoke your function with the same objects that would have passed a regular, like a first party language, if you want to call it that. And then you basically do the work and you just return. So that's kind of like our escape hatch, I guess, for languages. We just kind of came up with that a couple months ago. And what we're actually hoping for is that an ecosystem of language workers will come up. So you don't even have to worry about spinning up an HTTP server. You just literally just install like a Go module that you just run in your main, and then you just write these functions. And then when you deploy it, this thing will just run. It knows how to speak the protocol. And then, the end user experience is just writing the functions that you would have written in these other languages.
Yeah, it'd be trivial to do that in Go. Yeah. Hey, here's a question. For these functions, from invocation for invocation, does it is there state that exists in the program? Like for example, let's say that I have something that wants to compute a running average or something like that, right? So I'm gonna count, and let's say there's numbers that come into me. I'm gonna count how many numbers I've seen, and I'm gonna collect a running sum, and then I'll just spit out the sum divided by the number of things, right? If there's running state within the program and it's in say RAM somehow, that's pretty efficient, pretty quick. I could put in a database, but is there anything just state within the function that persists, or no?
Oh, I wish I didn't just have 10 minutes left.
Okay.
There's actually a whole different part of Azure Functions called durable functions. And that's actually one of the first features that I started working on when I joined the team.
Yeah.
It allows you to write kind of stateful functions and stateful workflows. And even an actor-like pattern that you can write. So what you just kind of talked about, kind of aggregating things over time, maybe collecting data points and kind of creating a running average.
Yeah.
Like an actor-like thing is perfect for it. Just keep feeding it messages. So you can actually create these things called durable entities, because I guess some folks in the actor community were saying, well, these aren't exactly actors, so don't call it that. So they're entities, but they have most of the properties of a virtual actor, so you don't have to worry about how to instantiate them or anything. They're just bits of code that run, and they're they're addressable by an ID. So you just say, just send this thing a message, and then and then within a single instance of an actor, you're guaranteed single threaded, so your code is super clean. So I'm not sure if you
I've done actors.
Yeah, so you've done actors before. So all the properties that you typically associate with actors, you do get with this platform. So behind the scenes, we are using queues and storage accounts and things like that to make sure to kind of keep the state. But for you don't have to worry about it. And then we also make sure that we try to keep as much in memory as possible, so that even between invocations, so the parts that you pay for, the invocations, even between those, we try to keep as much of the state in memory as possible, so the next invocation will be fast. So there's a lot of stuff we can talk about there, but it's so stateful functions, some people might call it maybe an anti-pattern, but we do see a lot of people needing it and using it pretty successfully.
Yeah. Cool. Okay, well, I think we got 8 minutes. What do you want to talk about in 8 minutes?
Well, I'm still wondering what you said. You wish you didn't only have 10 minutes, and that only took 2 minutes.
Oh no, there's a lot more stuff we can talk about. Because durable functions in itself is almost like a different programming model. You can almost think about functions as a service as almost like the simplest thing that you can do. To if I were to build a serverless compute platform, what would I do first? I'm well, functions, right? Mm-hmm. Stateless functions. But now,
so that would be like your hello world sort of step.
You can do a lot with it, right? But at the end of the day, it's a function, input, output, right? No state. But
you need state somewhere. It's not very useful, probably.
Yeah. But what you're but the thing is, now that we kind of almost as an industry, we kind of got this functions as a functions kind of programming model kind of figured out. What are the different programming models that we can now bring to the serverless world, right? So the one that I've always wanted, even before we had entities in functions, was I wanted actors to be to be serverless. Because quite often when you're writing actors, you're talking about, well, I need a cluster of stuff running somewhere. And the next thing you know, you're spending 80% of your time talking about how to keep the cluster running and not really thinking about how to write the code. But if all of that is abstracted away from you and you just write these actors, I think there's a lot of benefits to that.
Do you have anything like a supervision tree? One of the things that people, like for example, like there's different languages you can do actors in. Like one of them popular one is Erlang. And like one of the things people like about it is the OTP, the Open Telephony Platform. Forget telephony, and the thing they like about that is the supervision tree. So you have a bunch of actors. Maybe there's actors conceptually nested within actors. And what happens if one of these actors crash? What do you do about it, right? Like maybe like there's a pool of actors that handle sending people a welcome email. Well, if one crashes, just restart that one. But what if there's a complex pipeline where information is sent between them? Well, you might have to crash them all and bring them back up, or you just crash to the thing above you, right? Like, is there anything like baked into like these like Azure functions or Azure stateful functions that kind of gives you supervision tree like stuff, or can you construct it yourself? Or
not quite. Like you can definitely maybe try to construct it yourself, but I think it's a little bit more primitive than that. Like you can sort of think of actors, like the more traditional actors, where you have basically an actor in a mailbox. Okay. We do allow you to kind of interact with multiple actors at a time and almost create a lock between them.
Yeah,
it's a bit of an anti-pattern, but some people do want to be able to maybe like update, like a balance somewhere and also do something else. Yeah. We tell people like try to stay away from that as much as possible. But if you need it, you can kind of have almost like a distributed transaction. But beyond that, there isn't a ton more. Like for instance, like the supervision trees that we don't have anything like that.
Is there a way for one actor to start up another actor and like start it up and stop it?
You can definitely send it a message. So if you can start and stop something by giving a message, then yes. Otherwise, I would say no. Because at the end of the day, like they're pretty independent and they only talk using messages.
Yeah. Well, I was thinking if you could like shut it down, start it up and shut it down, then you could create a supervision tree like thing, like for if someone wanted something like that.
But in a sense, it's like because these things are supposed to be processing things, like at least the way that we built it, they're not like, even though conceptually they're long running, like the actors live forever.
Yeah.
But they're virtual actors, and then they like the amount of processing that they do is usually quite small.
Yeah.
So they're just doing like little things at once at a time. So so actually, I'm not super familiar with how how you would use like a supervision tree, for example.
Yeah.
But typically, what you would do in our case is literally like like these actors are just running things once in a while, doing some stuff, or you could be sending in a lot of stuff, but they're doing like little pieces of work. So if you actually wanted to kind of like get rid of an actor, all you're really doing is that the only thing you can really do is just erase his state. It's a state, because the next time you call it, the platform is going to create it again. So there's not really like starting and stopping.
Yeah. Okay. I guess there's nothing like a poison pill then with okay, cool.
I would love to learn more about that though.
We don't have time now, I don't think, but we can chat about
I keep scrolling over to see if my next meeting's canceled, but it's not. So
sorry. Too bad.
I shouldn't have said that, because hopefully they won't watch this and they'll be like, not important.
Well, I think that one thing's for sure, which is there seems to be like a lot of really interesting use cases for Azure Functions, and I'm pretty excited to have a look at the documentation and start poking around a little bit with it, and maybe think of some things that we can do. So maybe I think Charles and I will. We're currently working on a series where we're building out an MVC, but at some point, I think it makes a lot of sense for us to talk about a lot of different computer science type concepts. And so, as an example, like an actor, and what sort of situation you might use that, or like a supervised learning tree. When would be a good use case for that, and would we build something out using, say, Azure Functions or durable functions, and then kind of poke around with that and see, okay, what are the similarities, what are the differences, and then what is a poison pill, did you say, Charles?
Yeah, there's different ways of kind of like stopping an actor, and I don't know if maybe it's Akka. What language is that associated with? There was a language, a JVM language.
On the Akka.
Well, Akka, like it works with Java.
Scala.
That's what I was thinking. Like, so their actor model, I think, uses a poison pill. I don't remember if Erlang does. But then like something like Go has very low level. Like the Go routines are much more low level, but when I use them, I create my own actor model and I create my own supervision tree. It sounds fancy, but it's like once you see it, it's not that complex. But like a lot of these things have fancy names, but you know.
Yeah, that would be I think that would actually be something pretty fun to play around with, and then actually get the code for.
Yeah.
Well, anyway, Anthony Chu from Microsoft, Program Manager for Azure Functions. Thanks so much for joining us, and definitely would love to have you back on and maybe dive into some more stuff with functions.
Yeah, we'd love to come back. This was a lot of fun. Probably the most fun I've had in like a podcast / stream. So I'd love to come back.
Cool.
That's great.
Cool.
All right, I'm just gonna hop off in a very awkward manner, and I'll leave you to it. Thanks so much. Have a good day.
Thanks, Anthony.